This is a short tutorial on how to compile libnifalcon for Windows. Libnifalcon is an open source variation of the drivers for communicating with the Novint Falcon games controller, which can also be used for research and other things. So basically this open source library provides methods on how to control the Falcon without having to rely on the proprietary drivers provided by Novint. So if you want to compile on Windows in 2016, you will need four things. You will need a CMake, which is a cross-platform build tool. You will need a compiler that supports C++11, so I'm using Visual Studio 2013. You will also need the serial drivers that allow your computer to communicate with the Falcon. These are found on the FTDI website, which I'll show you in a few moments. And of course you'll also need the libnifalcon source code. So first thing you do is you want to get CMake, and that'll allow you to configure the source code to build on your system, depending on what compiler you have. So you get CMake from cmake.org, and it's pretty easy. Here 3.5 version 3.5 is released, so give that a shot. Should work. Next is you need Visual Studio 2013. That's the one I'm using. I think 2012 would work as well, but Visual Studio 2013 is nice because it is free essentially, in the sense that you don't need to purchase a license for the full version. There's a community edition, Visual Studio Community, and that basically is the full package in one. So all you need really is, I think, is to make a Hotmail account or a live account, and you can use that free of charge. So you will also need the FTDI serial drivers, and you find those on ftdi.com or ftdichip.com, as you can see here. I'll just go to the root website to show you. So this is the main page. You'll go to drivers and you'll click on the link for the D2XX drivers, and these basically allow communication through Windows. So the ones you will want are, depends on what application you're compiling, whether it's 32-bit or 64-bit. For this tutorial I'm going to be compiling everything in 64-bit. So download 2.12.6. You can download it's basically a zip file with a few libraries in there, and just extract that to your favorite library folder, and we'll access that with CMake later. Okay, so you'll have that downloaded, you'll have Visual Studio installed, and you'll also have CMake downloaded and installed. So the final part is you need to download the source code for the Novint Falcon, for the open source libraries libnifalcon. So the primary repository for libnifalcon is found here on GitHub. There's this guy called Q. And he's made a repository here for all the source code for libnifalcon. The problem with this repository is that it hasn't been maintained in quite a while, and it relies on the Boost libraries, the Boost C++ libraries, and they're quite difficult to compile and install, especially getting them configured with CMake. So people have been forking this repository to make a more friendly version of libnifalcon to compile. So I found this guy on GitHub, and he, let's see now, libnifalcon, did I have him? Y Balrid. Here we go. So there's this dude on GitHub, Y Balrid. Taken libnifalcon and done a few cool things to it. So what he's done is he's taken a fork of libnifalcon from this guy called Fabian, and Fabian, what he did is he removed the boost library dependency and basically used native C++11 to implement all of the old boost functionality. And Ballard just kind of simplified it and made it compile on more systems. So this is like a really usable library now. So what you do, I suppose, is the easiest way is just to download the zip of the current branch, and what we'll do is we'll right click, extract, and what I'll do just to make it easy is I'll paste it to my desktop. So we have a folder there, libnifalcon master. So you have that on your desktop, and the first thing you need to do then is open CMake, and you need to point CMake to the source code. So the source code is in here. You have all of these folders containing the source code and configuration files. So what you need to do is you need to point CMake to that. So CMake asks you where's the source code, and you navigate to your desktop, in my case, and click libnifalcon master. So you click OK and click configure. Now the build directory does not exist. Should I create it? Yes, of course. What compiler am I using? Okay, I'm using Visual Studio 2013, 64-bit. Yep. And blah blah blah. It'll start configuring itself. But any second now we're gonna get an error saying it can't find. Here we go. There we go. It can't find the serial library. So I've previously downloaded the serial library here and extracted it, and it should be called something like CDM CDM 2.12.16. So in here you have three folders. You have 64-bit, 32-bit, and static. So what you're going to want to do for your 32-bit, or in my case 64-bit, if you're compiling in 64-bit, you will include this this whole directory under libftdd2xx, and so desktop libnifalcon. No, we don't want to go there. We want to go downloads CDM, and yeah, that top level directory, that top level CDM is, you make that your include directory, because we want to include this ftd2xx.h, and by pointing to that directory, CMake knows where ftd2xx.h is. Likewise, for the library, we now need to point to the actual binary of the library. So this is where you need to be smart, because currently libnifalcon does not support static linking. So if you click on the static, you'll also see a 64-bit and 32-bit folder for the libraries, but you don't want to use those. You need to use the top level 64 and 32-bit libraries, and that's because they're actually dynamically linked, they're not statically linked. So in my case, I'm doing 64-bit, so I will link to this ftd2xx.lib in the AMD64 directory. So I navigate there in CMake, so CDM, AMD64, ftd2xx.lib, and click configure again, and there should be no errors. So you don't have to change anything else, everything should be fine, and after that you click generate. So now what's happened is we've generated a build folder. Here it says where to build the binaries. Oh, I forgot to put master in that directory address. So in fact, CMake has gone away and built a new folder for me for building the source, but doesn't matter. So where to build the binaries is this directory, and that's on my desktop as well. So by clicking generate, we've created this new folder where everything will be built. So it's libnifalcon build. Okay, we go into that, and you'll have a build folder, and you'll have a Visual Studio project set up here. So first thing you do, all you need to do essentially is click on the solution file, and that'll open up the settings and setup for compiling all the libraries and examples. So give it a few moments, to load the project. There we go. So on the right we have all of the projects contained within the libnifalcon source. So on the bottom here you have all the libraries you're going to build. I think there's like 3 library files that get built all together. And up here then you have all of the kind of example projects that get built with the library, just to kind of give you an overview of how everything works. So the compile is very easy. All you click is you right click on all build and click build. And currently we're building in debug and 64-bit, which is all correct. You're going to see lots of warnings and lots of shenanigans down here, but you really don't need to worry about it. All the warnings are basically complaining, C++ complaining to, or Visual Studio complaining to you that you're not using using all the types correctly, and not being very careful. But if it works, it works. You're going to get one error, and that error is to do with the compilation of one of the examples, and in this case it's falconmouse.cpp, which is in this example. And the reason for that is, for some reason, it still requires the boost library, but it actually doesn't matter, because if we look at our output, we see we actually have 12 succeeded builds and 1 failed. So the only thing that failed in that compile is the example. The actual libraries themselves compiled fine. So you can just double check that now. We'll go to we're in a build folder, and we click on lib, and you can see, lo and behold, we have our 3 library files. So if you wanted to now build a new project, create a new Visual Studio project for using libnifalcon, what you'd do is you create a new project. You'd make sure to include the header file, or the include directory included in the source. So it'll be libnifalcon master include falcon, and you'll include all of these directories, because each of them contain the header files for accessing the actual library. So you'd include these in your Visual Studio include path, and in your linker settings you'd go into your build folder, and in your linker settings you'd make sure to link against these 3 libraries. And once you've done that, you should have a successful project running. That's a good setup for another video, which I'll do soon. But the main thing is that this shows you how to compile libnifalcon on a relatively recent build, on a relatively recent machine in 2016, because it's actually quite an old project from around 2008, 2009, hasn't been maintained very well. So at least now we know how to build and how to get the libraries up and running, because it took me quite a while. So key things are, again, you need CMake, you need a C++ compiler, in this case Visual Studio 2013, you need the FTDI drivers, and you need the source. And again, the source is not the original source, it's one that's been adapted and maintained further by a GitHub contributor. So this guy Y Balrid, he's the guy you want to pull from, because you don't have to use any boost libraries. It's very easy to compile, like I just showed. So if you have any questions, please leave a comment, and hopefully I can help you out. I should be getting my Novint Falcon soon enough, so I've been kind of getting ready to use it by compiling all these libraries. So yeah, that's it. Signing off. All the best.